Alright, this is our first video of two on simple machines. So here we're going to give you some 6 examples of simple machines, and every other machine that you probably have ever seen or used is just some combination of these 6. In fact, some of them are even just combinations of each other. But this video is going to look at the first 3 here, the inclined plane, the wedge, and the screw, and our next we'll go into levers, wheel and axial, and pulley. So our first is an inclined plane. We looked at it briefly before. This is just simply another name for a ramp. I'm sure you've all used a ramp at some point. So what is it? It's a flat sloped surface. And how it does work is it allows you to exert your input force over a longer distance and therefore get more of a force as a result. So your output force will be increased. So your input force is going to be the force that you need to either push or pull up the inclined plane, while your output force would be the force you need to lift something up without using the machine. So input force is the force used with the machine. Output force you can think of as, if you weren't using the machine, how much force you would apply. Ideal mechanical advantage of this, again, this is going to be another formula. A lot of ideal mechanical advantages are going to be formulas. Ideal mechanical advantage is really just your the work that the machine does versus the work that you would have to do without the machine, and it is a ratio of that. So your ideal mechanical advantage, your IMA, is a ratio, and therefore your units are going to cancel and you're not going to get any units. But for an inclined plane, this is going to be equal to the length of the inclined plane divided by the height of the inclined plane. And again, you can think about it. The force that you need to exert over the distance of that plane would be the length, but really. And then if you didn't use it, that would be kind of like the height, just moving up the height. So that's your IMA of an inclined plane. Just a little activity while you're doing it, taking notes and stuff. Just what would increase your ideal mechanical advantage? Would that be increasing the height of the plane or increasing the length of the inclined plane? So if I were to quickly get my pen here and think about my IMA, remember your IMA is equal to your height. I'm sorry. Is equal to your distance, right? Distance of your ramp over your height, really. Would increasing the height or increasing the length of the plane give you a better IMA? So because it is a fraction, it is a ratio here, the larger the denominator, the smaller the number is going to get. The larger the numerator, the larger the number is going to get. So if I increase the height while keeping the distance the same, you would think that I would have a very steep ramp, as opposed to increasing the distance, I would have a very, very shallow ramp. This one here is going to give you a better ideal mechanical advantage because my numerator is going to increase while my height stays the same. Just some thought. A wedge is pretty much 2 inclined planes stuck together, and this is a device that you can think of. It starts out very thick at one end and then it tapers at the other end and makes an edge. Your axe or your knife is a great example of both wedges. And it's normally moving as well. So your inclined plane is normally stationary. A wedge you normally think of as moving across something. So ideal mechanical advantage here, you have length of the wedge versus the width of the wedge. And you can think of that width as being the height of that inclined plane if you think of a wedge as just 2 inclined planes stuck together. So here's one inclined plane, and there's your other inclined plane, and now I have a width here and it tapers at the edge. So the length of the wedge would be this value right here versus the height of the wedge, which would be this value right here. You can think of them as inclined planes. So you can see how this is very similarly related to the ideal mechanical advantage of an inclined plane. So let's look at that. How can you increase the ideal mechanical of a wedge? You increase or decrease the width. So again, our width would be this value here, and then over here would be our length. So our IMA here is going to be equal to our length over width. So if I increase my width, if I increase my denominator, this value gets smaller. If I decrease my denominator, this value gets larger. So if I have a very, very sharp edge with a small, I'm going to get a bit better IMA than if I have a wedge like that. Even though they both are wedges, they both are going to taper in. This one here is going to give me a more ideal mechanical advantage, and you can think of that a knife is better to have a steep angle here than it is to have a very wide angle there for cutting. Last one I want to look at in this video are screws. Screws you can think of as just an inclined plane wrapped around a cylinder. So if I move my face out of here, you can see this thread of our screw down here is the inclined plane, while the cylinder is the shaft of the screw there. How this is going to work is when you twist the screw, you exert an input force, and the threads increase the distance you exert that force, which is very much like an inclined plane. The screw exerts an output force, pulling it in, and the friction will hold the screw in place. This is why screws are used more than nails, because it has a better friction and it stays in place more. The ideal mechanical advantage of a screw, my face left. All right, there we go. Got my face back. Sorry about that. Our ideal mechanical advantage of a screw is going to be the length around the threads versus the length of the screw. So if I increase the length of my screw but keep my threads the same, then you can imagine those threads being very, very much spaced out, versus if I decrease the length of my screw and keep those threads the same, then they're going to be pushed together more. So you can think about it like that. So what will increase the ideal mechanical advantage of a screw? Threads close together or further apart. Again, looking at our formula, length of the screw is going to determine how spread out those threads are. If I increase my denominator, then my ideal mechanical advantage goes down. If I decrease my denominator, my ideal mechanical advantage goes up. Just basic fraction work for those. I guess I am getting the lever in this video. I apologize for that. A lever is lever or lever. You're welcome to use either pronunciation. It is just a rigid bar that's free to pivot or rotate on a fixed point called a fulcrum. So here we have our lever, which is the actual bar, and our fulcrum in this case is the little rock that he's pivoting it on. There are 3 different types of levers, and they all work a little different, and it's all about where our load is, or this giant rock would be our load here, versus our fulcrum, versus where we apply our force. But the IMA of a lever is just going to be the distance from the fulcrum of the input force divided by the distance of the fulcrum of the output force. So our output force will be where our load is as well. That's a pretty simple formula as well. If you look on page 129 in your book, there are a whole bunch of, it goes into detail on the 3 different types of levers. What I'd like you to do is to make a list of 20 examples of levers that you've seen or used. And then once you do make that list, I want you to trade it with a partner. I want you to label the class of lever as a first class, second class, or third class. And you can use your book as a reference guide for those. But you use way more than 20 different types of levers in your life. They are everywhere. Just takes a little thought on thinking about the different classes.